In video 3 you saw how a beltway feeder multiplies load by speed to hold a mass flow set point. Today we calibrate one properly. This is the video I wish someone had made me watch 20 years ago, because I've seen more raw mix problems traced back to a badly calibrated feeder than to any mechanical fault. Let's get this right. Before we calibrate, understand why a feeder that was accurate last year isn't accurate today. Belt stretch changes the geometry of the way span. Idler bearings wear and add friction that the load cell partially picks up. Material buildup on idlers changes the tare weight your controller thinks it's subtracting. Load cell drift, from age, from moisture ingress, from temperature cycling. And mechanical misalignment, a way idler that's no longer perfectly level, or a belt tracking slightly off-center. None of these are dramatic failures. They're slow creep. That's exactly why calibration has to be scheduled, not reactive. If you wait until dispatch complains or raw mix chemistry drifts, you've already been running wrong for weeks. Static calibration is the first step, done with the belt stopped. It has two parts, zero and span. Zero calibration, with the belt empty and stationary, you tell the controller, this is my empty belt reading. Every controller has a zero calibration function in its setup menu. You initiate it, let the reading stabilize, and the controller stores the tare value. Do this after any mechanical work on the idlers, after belt replacement, and as part of routine calibration, because tare is exactly what drifts from material buildup and bearing wear. Span calibration, this is where you apply a known, certified test weight directly onto the way idler, or use calibrated test weights hung from a calibration frame if your feeder has one built in. You enter the test weight value into the controller, it reads the load cell response, and calculates the span factor, essentially, the conversion between millivolts and kilograms for that specific installation. The critical thing technicians get wrong here, the test weight has to be applied at the actual weigh span, the exact length of belt between the idlers that defines the weighing zone, not just anywhere on the belt. Check your feeder's manual for the specified test weight application point. Get this wrong and your span calibration will be consistently off by whatever ratio your application point is out of position. Static calibration gets you close, but it doesn't account for everything that happens with the belt actually running and material actually flowing, belt speed variation, material distribution across the belt width, and dynamic loading effects. That's what dynamic, or material, calibration corrects for. The gold standard method in cement and bulk material plants is chain calibration. You run a calibrated test chain, a chain of known, certified weight per unit length, over the weigh span while the belt runs empty at normal operating speed. The chain simulates a moving material load with a precisely known weight distribution. The controller measures what it thinks the chain weighs, compares that against the chain's certified weight, and calculates a correction factor. Chain calibration should be run at multiple points across the belt width and, where the feeder design allows, run the chain through several passes and average the results, because a single pass can be thrown off by minor belt speed variation during the test. The other dynamic method is a material test, running actual material over the feeder for a set time or set totalized weight, then physically weighing that material on an independent scale, like a certified truck scale or platform scale, and comparing it against what the feeder totalized. This is the real-world check, and honestly, I recommend doing both, chain calibration to set the feeder up correctly, and periodic material tests to verify it's holding that calibration in actual operating conditions. How often should you calibrate? As a baseline, I run zero calibration monthly, span and chain calibration quarterly, and a full material test verification twice a year, but adjust that based on your feeder's duty, the abrasiveness of your material, and what your own trend data tells you. A feeder running raw coal with heavy dust and moisture variation needs more frequent attention than one running dry, consistent raw meal. Track your calibration results over time, not just pass or fail. If successive span calibrations are drifting in the same direction, say, always needing a slightly larger correction factor each quarter, that's telling you something mechanical is progressively wearing, and you should investigate before it becomes a bigger problem, not just keep correcting for it indefinitely. For tolerance, most cement plant feeders should hold within plus or minus 0.5% to 1% for critical dosing applications like kiln fuel, and you can accept a slightly wider tolerance, maybe 1 to 2%, for less critical bulk material transfer. Check what your specific process actually requires, don't just apply a blanket number. Let me leave you with the mistakes that actually happen on real plants. Calibrating with a dirty, material-caked idler and never noticing the tare has shifted. Applying the test weight at the wrong point on the weigh span. Skipping zero calibration and going straight to span. You need both, in that order, every time. Running chain calibration too fast or too slow relative to normal operating speed, which introduces its own error. And the big one, calibrating once at commissioning and then never again, because it was fine when we installed it. A weigh feeder is not a set and forget instrument. Treat it like the process control device it actually is. That's static and dynamic calibration, zero, span, chain calibration, and material verification, done properly and on a real schedule. In video 5, we move to loss in weight feeders, a different weighing philosophy entirely, where instead of watching a belt, you're watching an entire hopper lose weight over time. See you there.